Okay, so sometimes the variable is not on the left-hand side. So when we have something like x is less than 2, that's great. You know, we can have that, and the variable is on the left, and that's fine. And we've worked with things like that before. But maybe we have something like 17 is greater than x. Well, what we can do is we can rewrite that. We can walk it around so that the x is first, but then it's going to be less than 17. Now, think about this logically. If 17 is greater than x, then isn't x less than 17? And that's what we're saying here. We're saying x is less than 17. It's like the whole statement turned the corner. Now the x is first, the sign switched the other direction, and the 17 is on the right. It's just like if you were to say, I'm shorter than Bill, then it's the same as saying Bill is taller than me. You know, it's saying the same thing. I'm hoping that works. Okay. But we like to have the variable on the left-hand side because then we can use these rules that we've been working with. So, and it makes it easier to graph and do the interval notation and all of that. So you're just wrapping it around. So let's say you had negative 5 is less than or equal to x. Then you would wrap it around and you would say x is greater than or equal to negative 5. Okay? So we have to kind of think about the wording. If negative 5 is less than or equal to x, then x must be greater than or equal to negative 5. Think about that. Stew on it for a little while. Okay. So now in problem 10, we have this very thing. We have the absolute value over here on the right-hand side, but we don't really want it there. We want it on the left-hand side. So we're going to rewrite this as the absolute value of 5 minus 2x. And it used to be a less than, but now it's going to be greater than 7. Okay? So it's not the same as when you multiply both sides by a negative number or divide both sides by a negative number. It's not like that. We're just making the statement in a different order. Okay. Well, now this is a greater or situation. So we want to take the absolute value part, the 5 minus 2x, and say that is less than negative 7, or the 5 minus 2x is greater than positive 7. So that's what we were talking about, I think in the last video or the video before, where we were doing the greater or situation. You're going to have one going in the negative direction, like that side, and then the other is going to be going in the positive direction on that side. Now these are both inequalities that we have to solve, but we can do that. So subtract the 5, subtract the 5, I get negative 2x is less than negative 12. Divide by negative 2. Okay, that gives me x. I got to switch the inequality the other way, right? Because I divided by a negative number. So x is greater than 6. All right, keep that in mind. And then here we're going to subtract the 5. We're going to have negative 2x is greater than 2. Divide by negative 2. So that's going to switch that inequality to go the other way. X is less than negative 1. So if we were graphing this, nice big number line, 1, 2, 3, 4, 5, 6, x is greater than 6. So parenthesis 6 and going off that way. And then what do we have here at negative, oh, I wanted it to be negative 1 like that. We're saying x is less than negative 1. So we're talking about a parenthesis here at negative 1 and going off in that direction. Now, because we divided both of them by a negative number, they kind of switched places. Like the left one's going to the, anyway. But that's how it all works out. Interval notation is going to look like this. Negative infinity to negative 1, union 6 to infinity. All right.